Hello viewers, welcome once again to Esominofu online math class. Today I'm going to take you around the topic vectors. Okay, so watch my pattern of teaching these vectors. Watch the way I'm going to deal with vectors so that you actually understand what vectors are. Alright, if it is your first time of viewing, kindly hit the red button to subscribe to my channel. It gives you notification whenever a new video is uploaded. Alright, before we get into the topic, vectors, there is what we call types of quantities. Okay, physical quantities are of two types. We have the vectors and scalars. Normally, we have the fundamental and derived quantities, but that is not the classification we are going to look into today. All right, so when you talk about these types of quantities, it can be scalar or it can be vector. All right, so when a quantity is a scalar, it means it has just magnitude but no direction. Okay, so for you to say that a quantity is a scalar, it means the quantity is having only a magnitude but it doesn't have a direction. All right, when I talk about magnitude, I mean size. Magnitude is just size, right? So for instance, if I make a journey of 10 kilometers, the size, the magnitude of my journey is 10 kilometers, but I'm not making reference to the direction. So since this quantity lacks a direction, it is tagged a vector. It is tagged a scalar and not a vector. So therefore, for a quantity to be vector, it must have not just the magnitude but also a direction. That is why we say that vector quantities are quantities that have both magnitude and direction. Okay, so we've now seen a clear difference that exists between this scalar and vector. Vector has direction, while a scalar does not. That's just the difference between these two quantities. So what are the examples of scalars? For scalars, there are so many quantities that belongs to scalars. We can have the energy, we can even have the speed, we can have distance, we can have area, we can have volume, so many of them. All these quantities are scalar. They are scalar quantity, they have magnitude but no direction. So but when I talk about the vector quantity, I'll have my velocity, I'll have my acceleration, I'll have my displacement, etc. There are so many of them, so many quantities that belongs to vectors. Okay, so whenever a quantity is having both magnitude and direction, it is a vector. But when it has just magnitude, no direction, it becomes a scalar. All right, now there is what we call representation of vectors or notation or vector notations. How do we represent vectors? In printed works, vectors are represented by writing them in bold. For instance, if I talk about vector A, I can write A in bold. So this is a vector. Whenever you see this, you should know that this is a vector. If I have B, I can write in bold. This B is also a vector. Okay. Sometimes in manual works, you can represent vector like this by drawing a line under it. So this can still be a vector when you see something like this. That is how we represent vector. Or you can, maybe when I talk about vector AB, I can use an arrowhead to indicate the direction where the vector is going. So seeing all these things will tell you that the quantity being mentioned is a vector. That is what we call vector representation. We have another thing called the magnitude or the modulus of a vector. What do we mean by magnitude of a vector? From the name, magnitude is just size. Okay, magnitude is just size. So the length of a vector is just the magnitude of that vector. So the length of a vector, the size of the vector will give us the magnitude, because magnitude is size. Another name that can replace this magnitude is just modulus. So modulus is another name that can replace magnitude of a vector. And if I'm talking about vector A, for instance, this vector A, the magnitude of A is written as this, using two bars to cover it. Look at the magnitude of B, look at also the magnitude of this vector. So whenever you see this symbol, you know that I'm talking about magnitude. Don't forget that magnitude and modulus of vectors are synonymous, so they are the same thing. So you see that you call it magnitude of a vector, or you call it the modulus of a vector. Okay, now that is all a modulus, because we are still going to meet this during our course of study of episodes of my work in this vector, we are going to make this magnitude and we treat it very well. Okay, now we have the zero vector. When do we say that the vector is a zero vector? We'll coin the definition of this zero vector from the magnitude of a vector. When you find the magnitude of a vector and you find out that the magnitude of that vector in question is just zero, the size of the vector is zero, it means that the vector is a zero vector. If you don't call it a zero vector, you are free to call it a null vector. Okay, so when the magnitude of a vector is zero, it implies that that vector is just a zero vector, a null vector. It doesn't have size. We have the unit vector. A vector is said to be a unit vector if the magnitude is also 1. Unit means 1. Okay, so when the magnitude of a vector is 1, it implies that that given vector is just a unit vector because the size is 1. All right, so if, for instance, if I find the magnitude of a vector and it's giving me 1, it means it is a unit vector. If I find the magnitude of a vector and it's giving me 0, it means it is a zero vector or a null vector. That's just the meaning. So the definition of these vectors are coined from magnitude. All right, we have the negative vectors. Negative vector may not be a type of vector, but if you consider two vectors, and if the two vectors you are talking about are equal in magnitude, but their direction are different, it means that the one is a negative vector of the other. Their size are the same. Everything about them are the same, but the only difference that exists between them is just their direction. That is to say, if you have a vector A, for instance, the negative vector of A will now be negative A because they are going in opposite direction. Maybe this is vector A, and this one is vector B, and this one is another vector A, moving in different directions. If this A is equal to 5, for instance, and this is also equal to 5, because their direction are not the same, they are negative. Okay, because they are equal in size but direction are different. That is what we mean by negative vector. Okay, so a vector A is said to be a negative vector of another vector B if they are equal in magnitude but opposite in direction. That is just the definition of a negative vector. Okay, the next one here is equality of vectors. When do we say that two vectors are equal? Two or more vectors are said to be equal if their magnitude are the same thing. Okay, so whenever the magnitude of two or more vectors are the same, it means that the vectors are equal vectors. So that is what we call equality of vectors. I repeat again, two vectors are said to be equal if their magnitude are the same thing. At this point, I think I've given you an overview of the background knowledge you need to know about the topic vectors. Okay, stay tuned because we are going into the addition and subtraction of vectors right now. Okay, let us see the addition and subtraction of vectors, for instance. So if you have a triangle like this, where here is A, B, and C. Now, if this is moving in this direction and this is moving in this direction, while this one is moving in the opposite direction, this particular place is said to be the resultant of these two vectors AB and AC. Okay, because you can see it's opposing them is a resultant, and the addition of these vectors AB and BC will give us vector AC. So I can write here that vector AC, look at it, AC is something as, if you want to get the value of AC, don't just say that AC is equal to CB plus BA. It is wrong. When you have AC, take it in the opposite direction. AC is now the same thing as AB plus BC. You can see the movement. So AC is AB plus BC. That is how we take it. Assuming I want to find the value of BC. BC is not equal to CA plus AB. Rather, BC will now be BA plus AC. That is the idea here. If I want, let's say, BA. BA is not equal to AC plus CB. Rather, BA will be equal to BC plus CA. That's just the idea. Okay? So now, vector AC will be equal to AB plus vector AC is equal to AB plus BC. Okay, now assuming this vector is P, from A to B is P, and this is Q, you can now see that AC will now be equal to P plus Q, because AB is P, while BC is Q. So I am free to write that here is now P plus Q. This formula now, or this law here, is known as the triangle law of vector addition. The triangle law of vector addition. So we are going to apply this law in taking some addition and subtraction problems for vectors. So let's take some questions involving addition and subtraction of vectors. Alright, let's take the second question. If the vectors AB are represented by the sides AB, AC of a triangle ABC, what vectors are represented by line BC, line CB, line AD, where D is the midpoint of line BC? So since they say midpoint of line BC, let us make the BC to be on the base so that we can easily get the midpoint. That's the I there. Then here will be our A. So this midpoint, they say that where D is the midpoint, so I can call here D. Okay. So this is now our AD. And we are told that AB, AC of a triangle, and these sides are represented by AB. So which means line AB, vector AB is just A. So this is A. And vector AC is B. AC is B. Okay. Okay, you should know that this side should be equal to this side. Okay, this is vector A and B. This and these are equal since we are told that D is the midpoint. So they now want us to get vector BC. So let us see. BC, remember the way we do it. BC is the same thing as BA plus AC. You go in reverse direction. BC is the same as BA plus AC. So for the first question, where I have BC, BC is the same thing as vector BA plus vector AC. That's just it. So BC is BA plus AC. So my BC will now be BA. Instead of saying AB, we said BA. So this A will turn to negative. Okay? Because we said BA instead of AB. Whenever it does not go alphabetically, it must turn to negative. Plus AC is just B. So this is B, which you can write properly as the vector BC is the same thing as B minus A. That's just the value for this one, B minus A. So let us go for the second question. In the second question, I will have vector CB. CB is the same thing as CA plus AC. Look at it, CB. You go in the other direction. So CB will be CA plus AB. So it will be CA plus vector AB. Okay? So my CB will now be CA. Instead of AC, we say CA. So this B will be negative plus AB. Our AB is A. So I can write it properly as CB equals A minus B. Alright, so I've just answered the second question. Let's go to the third one. So let's take the third one. In the third one, we'll have vector AD. AD is something as AB plus BD. Okay? It will be AB plus BD. That's just it. Because they say AB, you go in opposite direction. Instead of saying AB is DB. No. So AD is AB plus BD, which I've written. So my AD will be AB. My AB is already A plus BD. BD is the same thing as half of BC, because we are told that D is the midpoint. So BD is just half BC. So I can call it half BC. But we solved for BC in A, and we got that our BC is just A. Look at your half. BC is A minus B, or B minus A. Let's see. BC is BA, so it's B minus A. So BC, we got a number of option A as B minus A. So if I open the bracket, I'll have that vector AD is A plus half B minus half A. Okay, and A minus half will just give us A minus half A is just half A plus half B. If you want to factor out properly to organize your work, you can just write that vector AD is something as half bracket A plus B. Look at A, look at B, and half is common. I factored out, so you can see that vector AD is something as half A plus B. Okay, so let's take another problem. Okay, the next question says PQR and these are the vertices of a quadrilateral such that A and B are the midpoints of the sides QR and PS. Show that AB is equal to half QP plus ROX. Quadrilateral must have four sides. We don't know the particular quadrilateral they're talking about, but they talked about QR and PS. So I have to arrange it this way, PQRS, such that I can have my PS and QR, just like they have said. Okay. Now, we are told that A and B are the midpoints of, so QR is A, midpoint A, coming here, midpoint is B, according to the question. If I like, I can join together. Okay. Now, we are asked to show that AB is equal to this. So let us actually know the value of this AB to see how it may have relationship with this particular term we are asked to prove, this equation we are asked to show. Okay, now AB, vector AB can be seen in two ways. I can go to my left, I can go to my right. So AB is not BP plus PQ plus QA. Rather, AB go in reverse direction. So AB will now be AQ plus QP plus PB. This is just my AB. I'll leave it as my equation 1 because there is nothing else I can do with it. Also, the same AB can be seen as AR plus RS plus SB. Okay, SB. That is my AB. Now, this is equation 2. There is nothing else I can do to equation 2 because nothing, honestly, nothing. So let us try to add the two equations to see if you can get a useful thing. So if I say equation 1 plus equation 2, I'll have AB plus AB will give me 2AB equals, if I add, I'll have the sum of everything here. I have AQ plus QP plus PB plus AR plus RS plus SB. That's just the sum. Now, the trick we are going to use here is that we are going to make similar sides to be together. For example, the first one I'm seeing here is AQ. AQ is in the same line with AR. So I will match AQ and AR together, or RA as the case may be. So 2AB equals AQ plus, let me look for AR or RA. Anyone I see, AR, the same line. So I have AR, I will separate, plus coming down here, I have PB, and PB and BS or SB are in the same line. So let me look for PB and SB or BS as the case may be. So here I have PB plus SB, SB. Then plus what is left here is this QP, I've not touched it, QP, then plus ROS, I've not touched it, ROS. Now let us be critical here. AR, look up here, AQ is going in this direction, AQ. Why AR is going in this direction, AR. So they are moving in opposite direction, but they are equal because we are told that A is the midpoint. So AQ is equal to AR, but they are going in opposite direction. Therefore, this AR is just like negative AQ. Hence, I can write 2AB equals AQ minus AQ because it's negative AQ plus the same thing here. PB is going this way, P to B. Why this one is S to B, reverse direction, but they are equal, just negative. So this SB can be seen as negative PB, then plus QP plus RS. Okay, now 2AB equals, this is 0 plus QP plus RS. All right, so now 2AB is equal to QP plus RS. So AB will be dividing this by 2. So my AB, or rather 2AB, is QP plus RS from there, because 0 is nothing. Then divide both sides by 2. AB is equal to, over 2 means half, equals half QP plus RS. Okay, and that is what the question is talking about. So we have shown that. So from vector, we've shown that AB is equal to half QP plus RS from this diagram. Let us take one more question. So the next question says, if ABC is a triangle and M and N are midpoints of AB and BC respectively, show that MN is equal to half AC. So let's assume that this is a triangle in question. Okay, if here is A, let here be B, and here is C, this will enable us have AB and BC independently. Okay, now, and we are told that M is the midpoint of AB. So here is M, midpoint of AB, and N is the midpoint of BC. So here is N, midpoint of BC. So if I like, I can join M and N together. So we are asked to show that MN is half AC. And MN can be seen in two ways, just like we saw in the previous question. My MN can be, MN is not NC plus CA plus AM. Rather, MN, opposite direction, will be MA plus AC plus CN. There is nothing I can do to it. I call it equation 1. Also, MN can be seen as MB plus BN. MB plus BN. If you go the other way around, MN is not BN plus BM. Rather, MN is MB plus BN. So this can be called equation 2. Okay, now there is nothing I can do here. The only option I have is to sum up equation 1 and 2. So equation 1 plus equation 2, I have MN plus MN will give me 2MN equals, we have MA plus AC plus CN plus MB, then plus BN. All right, now let us check the sides that line together, just like I have MA here. MA, I know that MA and MB or BM are in the same side. So let me look for MB. So 2MN will now be MA plus MB. Let me join it with MB. Let me separate. I've removed this. Now, AC is alone. But the next thing I have here is CN. CN and BN are in the same side. So I can combine this and this together. So I'll have plus CN plus BN. Then plus what is left here is just AC. So again, 2MN equals MA. Since here is the midpoint, MA and MB are equal. But MA is going this way, while MB is going the other way around. All right, they are equal, but they are negative vectors. So MA is equal to minus the negative of MA again. So I can write as MA minus MA. okay, plus look at vector Cn here. Cn is the same thing as Bn, but Cn is going here, while Bn is going the other way. They are equal in magnitude but opposite direction. So Bn can be written as minus Cn, then plus vector AC, okay? So that 2mn will give us, this is 0, this is 0. So we are left with vector AC, okay? Now, to get mn, I'll divide both sides by 2. I'm dividing both sides by 2 to get mn. So therefore, vector mn will give me half AC. Alright, so this is just the value for vector mn. If you've enjoyed what you've watched, kindly subscribe to my channel and await the subsequent episodes that will come out on the topic vector, because we are going to take time to deal with this topic one after the other. Thank you so much.